Hi everyone, welcome to Weekly Essential number 9. If you will, get that paper out and we'll start going over some of these problems together. All right, so number 1, a reading teacher recorded the number of pages read in an hour by each of her students. The numbers were as follows: 44, 49, 39, 43, and so on. So we have a data set and it's asking us to find the 5-number summary and then find the range, interquartile range, and the mode. So if you guys remember, the first thing you need to do when you have a data set is put your numbers in order from least to greatest. So if we notice, the first number that I see that I need to get rid of is 39. So I'm going to write my new data set 39. Then I see 43. Okay. Then there's two 44s. So 44, 44. There's a 45. I see a 49 and another 49, so two 49s. I see a 50 and a 51. Okay, so I've gotten my data set in order. I can easily go do my minimum and my maximum. Minimum is the smallest number, maximum is the largest. All right, so then the interquartile range, the lower quartile, the median, and the upper quartile. I need to split the data in half. So there's 1, 2, 3, 4, 5, 6, 7, 8. I have 9 values. So that means that I can have 1, 2, 3, 4 on the lower end, my median value, and 1, 2, 3, 4 on the upper. So my median here is 45, and this takes my data and splits it into 2 pieces. So the median in the center, we don't include that. Then I have a lower half and an upper half. So Q1, if you remember, is the median of the upper half. So I like to just draw a line straight in the middle. So 43 and 44 is the number between 43 and 44. You would do 43 plus 44 and divide it by 2, and you would end up getting 43.5. So 43.5 is here. And then you do the same at the upper quartile. So split it in half. 49 plus 50 divided by 2 to find that number in the middle. And you're going to get 49.5. Okay, so the range, if you remember, range is maximum minus minimum. Well, my max was 51. Minimum was 39. So 51 minus 39 is going to give you a 12. Interquartile range, Q3 minus Q1, so 49.5 minus 43.5. When you plug that in, you should get a 6. Mode is the number that occurs the most. So if we look, there's 2 numbers that are occurring the most. I see a 44 and a 49. So this data set has 2 modes. All right, number 2. So you have a triangle and you're going to translate over the vector 3, negative 4. All right, so that vector tells you some direction, right? So this is telling you x values go left to right. So this is telling you to go right 3, and negative 4 is telling you to go down 4. So I'm just going to take every point and move each point right 3, down 4. So B, 1, 2, 3 to the right, 1, 2, 3, 4 below. That gets a B prime. S is going to go 1, 2, 3 to the right, 1, 2, 3, 4 below. That's S prime. And X goes 1, 2, 3 to the right, 1, 2, 3, 4 below. There's X prime. And there's your new triangle. All right, so XBS is the pre-image. X prime, B prime, S prime is your image. And don't forget the primes. And it asks you for the resulting coordinates. So you could just come over here and say, okay, well, X prime is negative 1, negative 2. B prime is 2, negative 1. And that's an S, not a C. S prime is 2, negative 3. Okay? That's number 2. So number 3, okay, for what value of n are the lines 7x plus 3y equals 8 and nx plus 3y equals 8 perpendicular? This question is just a little bit challenging, so we need to think. Perpendicular lines. So there's two. We've seen parallel lines. We've seen perpendicular lines. What do we remember about perpendicular lines? What about, there's something special about their slopes. So if you remember, their slopes are opposite reciprocals, okay? So I'm trying to figure out the value of n that would make this line perpendicular to this line. So could I take 7x plus 3y equals 8? Could I solve it for y? Subtract 7x from both sides. 3y equals negative 7x plus 8. Divide by 3, and I get y equals negative 7/3 x plus 8/3. Okay, so the slope here is negative 7/3. So the perpendicular slope is going to need to be the opposite reciprocal. So if this is negative, it's going to need to be a positive, and the reciprocal of 7/3 is 3/7. Okay, so based on the original, I need the slope of this line right here. This needs to have a slope of 3/7 in order to be perpendicular to the first. All right, well, I don't know what the slope is yet, so I'm going to do the same thing. I'm going to leave that in, and I'm going to solve this for y. So I'm going to subtract nx from both sides. 3y equals negative nx plus 8, and I'm going to divide by 3 everywhere. I get y equals negative n over 3x plus 8/3. Okay, so we said in order for this line right here to be perpendicular, it needs to have a slope of 3/7. Okay, I don't know what this n is equal to. So I need, for this guy right here, this entire slope needs to equal 3/7. Okay, so I'm going to set up an equation. I need negative n over 3 to equal 3/7. And remember, it said for what value of n. So it's basically telling you that at the end you're going to solve for n. So I've set up a fraction equals a fraction. Do you guys remember how you would solve a fraction equals a fraction, what you do there? If you just said cross multiply, you're right. Okay, so I'm going to cross multiply. So 7 times negative n is negative 7n, and 3 times 3 is 9. So negative 7n equals 9. I'm trying to get n by itself, so I divide by negative 7. Well, that gives me n equals negative 9/7. Okay, so this is your final answer. It asked you to solve for n. You did. Okay, so how could I go back and check this if I wanted to? Remember, n is right here. So if you wanted to see, okay, basically what we're saying is this value of n right here, when I plug this in for n here, this fraction is going to need to become 3/7 in order for this to be perpendicular. So let's just see. Let's take my negative 9/7 and plug it in here. So negative n over 3. Where there's an n, I'm going to put negative 9/7. So I'm going to get negative 9/7 over 3. So a negative is a positive. So I get 9/7 over 3. Do you guys agree with me that this denominator is like over 1? We don't really like fractions over fractions. So do you guys remember you can multiply by a reciprocal? 1/3 times 1/3. That would go away. That leaves me with 9/21. And 9/21, they're both divisible by 3. 9 divided by 3 is 3. 21 divided by 3 is 7. And look, that works. That gave me the slope of 3/7. So this n value worked. So that's a pretty challenging question right there. Okay, so if you need to go back and look at that again, I would encourage you to rewind or pause and go back and look at this one more time. This is a great, number 3 is a great EOC question that you guys may see coming up soon. Okay. All right, number 4, Alice finds her flower bulbs multiplying each year. She started with 24 tulip plants. After 1 year, she had 72 plants. 2 years later, she had 120. Find a linear function to model the growth of Alice's bulbs. Okay, so she started with 24. Then she had 72. Then she had 120. It says write a linear function. Well, what do we know about linear functions? Linear functions have constant rates of change, don't they? That means that they're changing by the same amount. Well, let's see. How do you change from 24 to 72? So 24 plus something is 72. Remember, you can work backwards. 72 minus 24 gives you 48. All right, how would you go from 72 to 120? Are you adding 48 again? You are. So look right there. That is your rate of change. So you're changing by 48. Well, if it's asking for a linear function, remember a linear function is mx plus b. M is your slope or your rate of change. B is what you started with. Okay, well, we just found our rate of change. F of x is 48x, and then a starting value. Well, didn't it say she started with 24? So doesn't that mean that this 24 is my starting value? So plus 24, there you go. Okay, number 4 is done. Linear function. Flipping over, number 5. Is the point 3, -1 a solution for this system? Well, if a point is a solution to an equation, when you plug it in, it makes a true statement. If it's a system, you have to plug the point into both equations, and they have to both be true. So this is x, this is y. I'm just gonna, I don't know about you guys, but if I have 2 equations, I think I might just go ahead and plug in and see what's true. So everywhere I see an x, I'm putting a 3. Where there's a y, I put a -1. Okay, there's a y, -1 equals 2 minus, there's an x, that's the 3. All right, -1 equals 2 minus 3 is -1. Boom. Oh, that first one, it worked, didn't it? So let's check the second one. 3 minus 2, oh, there's a y. So 3 minus 2, where I see a y, I put a -1. Equals 2 times, there's an x, I put a 3. So now we multiply. So 3, so -2 times -1 is 2. So 3 plus 2 equals 2 times 3 is 6. All right, 3 plus 2 is 5 equals 6. Is that true? Nope. So the point worked for the first equation, but it didn't work for the second. So if this point only works for one, can it be a solution to this system? No, it has to work for both. Okay, so number 6, solve the equation for W. So there's that W. I need to isolate it. So I'm going to subtract 2L from both sides. All right, so that goes away. I get P minus 2L equals 2W. They're not like terms. P and L are not like terms, so we can't combine them. Okay, so now I'm going through, I'm going to divide everything by 2. There's 2 things you can do here. Okay, you can divide P minus 2L all by 2 and leave it that way. All right, and that would give you W equals P minus 2L over 2. That works. Or when you have P minus 2L equals 2W, you could divide each term by 2. Okay, what's going to happen is this 2 here is going to cancel. So you would end up with W equals P over 2 minus L. Both of these are correct. Okay, so you might want to just be prepared that you know that they mean the same thing. Okay, number 7, write the recursive formula for the following sequence. And there's a reminder. Here's your recursive formula. A1, first term, equals what? AN equals AN minus 1 times R. You only need 2 things here. You need the first term. You need R. Remember, R is the common ratio. Ratio means What are you multiplying by? This is a geometric sequence, right? Geometric, you multiply. Arithmetic, you add. So I need to figure out what I'm multiplying by. Does anybody notice anything special? Negative, positive, negative, positive. That tells you, hey, I bet I'm multiplying by a negative. Negative 4 times what gives me 8? Negative 2. Does 8 times negative 2 give me negative 16? Absolutely. Negative 16 times negative 2? Perfect. So my R is negative 2. Your first term here is negative 4, so we can fill in. A1 equals negative 4. AN equals AN minus 1 times negative 2. Okay? So there we go. So last one. Given f of x equals 2x minus 1, find f of 7. Notice, where there was an x, we put a 7. So that just means, hey, where you see an x in this equation, put a 7. All right, so 2 times 7 is 14. 14 minus 1, 13. So what that means is f of 7 equals 13. Now I want to take this a step further. If I told you to write f of 7 equals 13 as an ordered pair, could you do that? Remember, that's x, and f of x is the same thing as y. So the ordered pair, if you were asked, the ordered pair would be 7, 13. Good. So for B, it says to do this, use the same function, plug in a negative 7, basically. So f of negative 7 is 2 times negative 7 minus 1. 2 times negative 7 is negative 14 minus 1, negative 15. So f of negative 7 is negative 15. And if I asked for the ordered pair, could you do that? X is negative 7. Y is negative 15. Good job. So that was some mixed practice. So make sure you guys know how to do these. If you need to go back and watch any parts again, particularly that one on the front where you solved for n, go back and do that. Good job.